All right, graph the solution. What we have here is what's called a system of inequalities. What you do is you graph each inequality one at a time, and you shade each side one at a time and find out where the two shadings meet. Wherever the two shadings meet is going to be your solution. So let's take a look at each of these. All right, these are already both slope-intercept forms. So remember, slope-intercept form is y equals mx plus b. So when I compare this first one and that first one right there, the number in front of x is my slope. So my slope is going to be -1 or -1 over 1. And my y-intercept is going to be -2. So let's graph that first. Okay, now this is a negative slope, but I always start out at -2. So I'm going to put a dot at -2. My slope is negative up 1, left 1, up 1, left 1, and I make as many dots as I can. So far graphing this is no different than graphing a regular equation up until now. Now my symbol here is less than or equal to, which means I draw a solid line. So fortunately, I have a solid line up here waiting for me. Let's draw that out. Now the reason why it's a solid line is the fact that it's or equal to, and or equal to means we include the line. So or equal to. I'm not done yet with this problem though. I have to shade a side. So since it's less than or equal to, I'm going to shade the bottom side below the line like this. Okay, now this is just one of my lines. Clearly I'm not done. This is just one of my lines, but right now I've shaded one of my sides. So according to this, any of these points are going to be a solution to that top equation right here. But I need both equations graphed to find my final solution. So let's graph U. Let's focus on U in blue. Okay. This one, my slope is going to be -5. So m is -5. I'll write 5 over 1 to keep it as rise over run. And my y-intercept is going to be +2. Start out at +2. This is a negative slope, so I'm going to go up 1, 2, 3, 4, 5. I can't, so I'll go down 1, 2, 3, 4, 5, right 1, put a dot there. My dots overlap, and then I can't do any more. Again, I need to focus on the fact that I have a greater than or equal to symbol, which means when I graph this, it's again a solid line. Okay, so again, solid because I'm including the line because it's or equal to. Now this has me greater than, which means I'm graphing above this line. So let me shade above this line. It's going to look like this. And what's going to happen once I start shading a little bit more and once I get to the bottom is we're going to see where my blue and my yellow meet. And the part that my blue and yellow meet and create that little green area that you can barely see right there, that is going to be the solution to my system of linear equations. I'm sorry, linear inequalities. What I like to do with these is I like to label it R for region, like that. But this is my area that gives me all of the possible solutions for both of these. When you graph a system of equations, you are trying to find an area where both shadings meet. And in this case, both shadings meet in this little area down here. And if this were to keep going and that were to keep going, you would have more. But I can pick a point like 2, -5. Okay, 2, -5 is a point right there. That's in my green area. If I were to label 2x and -5y and plug them in for both of these, that will work. Along with any of these points down here, those will all work.